Last class we have find out how to find the Fourier transform for a particular function, and there are some important Fourier transform. One of them we have deduced what is that Fourier transform for that particular function. Now today we will start with some more important Fourier transform. So number 2 is that if the function fx is e to the power minus a mod x, where a is greater than 0, then Fourier transform of that function means f of x, this is twice of a square plus s. Okay, so this is our first important result. So here the function is given e to the power minus a mod x. Now we will show that Fourier transform for this function is 2a by a square by s square. So let's start then. Then f of x, this is integration minus infinity to infinity f of x e to the power isx dx. Now see that this function is even function, right? Therefore we can evaluate this function as twice of Fourier cosine transform of that function, right? So let's evaluate that thing only. So f of fx is twice 0 to infinity fx cos of sx dx, to 0 to infinity fx is e to the power minus a x cos of sx dx. So we remove the mod because now region of integration is positive. So this will be, so as this is a improper integral, therefore we will take limit as t tends to infinity 0 to t e to the power x cos of sx dx. So this is twice of limit t tends to infinity e to the power x by a square plus a square into a cos sx plus s sin sx, and limit is 0 to t. Okay. Now let's put the limit. So for t it will be twice of e to the power at by square a cos st plus s sin st. Now for t equal to 0, so here one minus is there. For t equal to 0, it will be minus 1 by a square by s square, and this is minus a, and other part is 0. Now here also we forget to write that limit t tends to infinity. This will come. So ultimately the integration becomes twice limit t tends to infinity e to the power minus at a square plus a square minus a cos of st plus a sin of st minus of this one. Now see, this part does not contain any t, therefore we can bring that out of the limit. Now for t tends to infinity, as a is positive, so e to the power minus at, as t tends to infinity it will be 0, right. Now for t tends to infinity, this part cos of st and sin of st, so these two function as bounded function, so t tends to infinity it will be a bounded function only, so 0 into a bounded function, so ultimately this is 0, therefore only these terms will be remain. So this is twice a by a square plus a square. Okay. Now we go to that next important Fourier transform. Now number 3 Fourier transform is that if the function f(x) is one for mod x less than a and 0 for mod x greater than or less, right, as otherwise, then f of x, this is 2 sin s a by s when s not equal to 0, and this is 2 when s equal to 0. Okay. Now let's solve this one. So similar sort of one result we have proved. So in that case we have taken that a as 1. Now this is general case. So let's find out this integration f of x. So this is integration minus infinity to infinity fx e to the power isx dx. Now this will be, we break this limit of the integration in the following the definition of the function. So first integration will be minus infinity to 0 fx e to the power isx dx minus infinity to minus a, right, because the function fx is looks like, suppose this is x axis and this is y axis, and this is minus a and this is plus a, then in this region minus to a fx is 1, suppose this is y equal to 1, so this is fx function, and for this is less than, otherwise means either it is less than minus a or greater than a, it is 0. So functions is looks like this sort of function. So this is discontinuous as minus a and plus a, so this is the function. So this part the function's value is 0 when the minus infinity to minus a, and next part will be minus a to a, so we write down this one. So in this case the function value will be 1. And last one, that is that a to infinity, so in this case also fx is 0. So this one is 0. Now next one, only function fx is 1, e to the power ixx dx, and this is also 0. Now it will be e to the power isx by ix, limit is minus a to here. Okay, now we first put the limit x equal to a, so it will be ix a minus e to the power minus is a by is. Now if we try to find out in a sine function this one, then we can write this as a 2 by s e to the power isa minus e to the power minus isa by 2 of s, 2 of I. So this is 2 by s sine of sa. Okay, therefore we can represent this function f of fx 2 of sine sa by s. Now this is not true when s equal to 0. Therefore what will be the result if s becomes 0? Now we put s equal to 0 here in the definition, then e to the power I 0 x, so it will be e to the power 0, so this is 1, so only this integration will remain minus a to a 1 dx, so this value will be twice of a. So this is not equal to 0. So this is twice of a. So this is the Fourier transform. F of fx is 2 sine by s when s not equal to 0 and equal to 2a when s equal to 0. Now number 4, Fourier transform. So in this case the function is given that if fx is e to the power minus ax where a is greater than 0, then Fourier sine transform of the function fx is s by a square plus a square. Okay, now let's find out the solution. F of s of fx, so this is his integration 0 to infinity fx sine of sx dx. So this is the Fourier sine transform definition, 0 to infinity fx sine sx dx. Now this is 0 to infinity fx is e to the power minus ax sine of sx dx. Now this integration we need to find. Now we know that, so before that we have to also take that limit because it is a improper integral 0 to t e to the power minus x sine of sx dx. Now this integration e to the power minus ax sine of sx, this one is e to the power minus x by, so that general rule is that e to the power ax sine of bx, if this integration is given, Then we find the integration of this one as e to the power x by e squared plus b squared a sin bx minus b cos bx, this one. So e to the power x sin of bx dx is e to the power x a square plus b square a sin bx minus b cos bx. Now in this equation a is our minus a and b is s. Therefore this integration will be limit t tends to infinity 0 to t and 0 to t. So we will write the integration e to the power minus x by a square plus a squared minus a sin of sx minus s cos of sx integration 0 to t, right. So this is limit t tends to infinity. So it will be e to the power minus at by a square plus a square minus a sin of st minus s cos of st. Now for x equal to 0 it will be 0, so it is 1 by a square minus 1 by a square plus a square, and then for 0 it will be minus s right. So we can write this equation. So similarly the previous case, so t tends to infinity, a is greater than 0, so it is e to the power minus infinity, so basically it is going to the 0 and by a square plus a square. So and this is a bounded function, so ultimately this is 0, so only remaining terms is by e square plus e square. Okay. Now we go for the next Fourier transform. Now this is that same function fx is e to the power x, a is positive, and then Fourier cosine transform of the function fx is s by a square by a square by a square. Okay, let's, so this is not s, so this is a by. Okay, so the Fourier cosine transform of this function fx is a by s square by plus s square. So let solve this one also. So here also similarly f of cos of fx, so this is integration 0 to infinity, fx is our e to the power a minus x and cos of sx dx. Now this one is by the same, so here our integration is this one e to the power x cos of bx dx, right. Now for this integration, the integration value is e to the power x by a square plus b square minus a cos of minus is not there. So e to the power x cos bx dx, this integration is a cos bx plus b sin bx dx. Okay. Now to come to this integration, so limit t tends to infinity 0 to t e to the power minus x cos of sx dx. So limit t tends to infinity by this formula. So where a is minus a and s is b. B is s, so it will be e to the power minus x by a square plus b square minus a cos of sx plus s sin sx, and integration limit is 0 to t. Okay. Now for limit x equal to t, e to the power minus a t by a square plus a square minus a cos of st plus a sin of st. Now for 0 it is 1 by e square plus c square minus a. Now for t tends to infinity, this is goes to 0 and this is a bounded function, so this is ultimately goes to 0, so only these terms will remain, so it is a by a square plus. Okay, so we find the Fourier cosine transform for this function e to the power x.